Jai Gurudev. Continuing from the last video, our next question is p square plus 7p minus 60. So here we have got three terms: p square first term, 7p second term, and minus 60 as the third term. Now here we find that plus 7p is the middle term, so we'll try to split this in such a manner so that we get plus or minus. If we do by two numbers, we get 7, and these two numbers, if we multiply, then we get minus 60. So we know 12 minus 5 is 7. Similarly, if we multiply 12 into 5, we get 60. Therefore, our two numbers here can be 12 and minus 5. So now we'll split the middle term. P square plus 12 minus 5 within bracket, then outside p minus 60, which can be written as p square plus 12 minus 5p minus 12 into 5. Now here, since it is given minus, and I have to match this with the formula, which is x square plus a plus bx plus ab. So what I can write here, I can write it plus, and then value wise here minus. So 12 into 5 becomes minus 60, since plus and minus will make it minus, which is equivalent to this formula: x square plus a plus b x plus ab. So here you find x square is p square, where p is equal to x, plus here plus a plus b. Now here it is 12 minus 5, that means a is 12, b is minus 5, x here is p, plus a into b. Here a is 12 into b is minus 5, which equals x plus a and x plus b. So comparing this, we get here x is equal to p, the variable, a is equal to 12, b equal to minus 5. Therefore, this expression p square plus 12 minus 5p plus 12 into minus 5 can be written as p plus 12 within bracket, and in another bracket p minus 5. So these are the two factors of this expression, p square plus 7p minus 60. Next question is z square plus 6z minus 16. Here also, as we can see, we have got three terms: first term, second term, and third term. So 6z is the middlemost term. So we'll try to split or break 6z in such a manner that if you add or subtract two numbers, we get 6z, and if you multiply those two numbers, we get minus 16. So we can take those two numbers as 8 minus 2 is 6. 8 into minus 2 is equal to minus 16. Therefore, this expression, the middle term, can be splitted with 8 and 2. Therefore, we'll write z square plus 8 minus 2 z minus 16. or z square plus 8 minus 2z plus 8 into minus 2, which is equivalent to this expression x square plus a plus b x plus a into b. So here x is equal to z, that is the variable used here. A is equal to 8, b is equal to minus 2. Therefore it can be written as z plus 8 within bracket and then z minus 2. So these are the two factors of the expression z square plus 6z minus 16. Next question is p square plus 1.5p plus 0.5. So similarly, here we have got three terms, and first one is p square, second term is 1.5p, third term is 0.5. So accordingly we'll split or break 1.5p, which is the middle term of this expression, in such a manner that if we add or subtract two numbers we get 1.5p, if we multiply those two numbers we get 0.5. so those two numbers can be 1 plus 0.5, which is equal to 1.5, and if we multiply 1 into 0.5 it is equal to 0.5. So our two numbers for splitting the middle term is 1 and 0.5. Therefore the expression will be written as p square plus 1 plus 0.5 p plus 1 into 0.5. So comparing this with the fourth identity, which is x square plus a plus bx plus ab, we get here x is equal to p, a equal to 0.5, b equal to 1. Therefore the above expression can be written as p plus 1 within bracket p plus 0.5. So these are the two factors of the expression p square plus 1.5p plus 0.5. Question number 5. Divide. Number 1, 121 x to the power 4 divided 11x. Now 121 divided by 11, so 11 will cancel 121 11 times, so we can write here 11. Next, x to the power 4 divided x can be written as x to the power 4 minus 1. This follows from the laws of exponent, where we know a to the power m divided a to the power n is equal to a to the power m minus n. So since we have got x to the power 4 divided x, here x means power will be only 1, since nothing is mentioned, so power will be 1. So x to the power 4 divided x to the power 1, so a to the power m divided a to the power n, which equals a to the power m minus n. So x to the power 4 minus 1, which equals 11 into x cube. 4 minus 1 is 3. So this is the final answer. These three questions will be homework. All of you try by yourself. Next question is 63 p cube divided 9 p square. 9 sevens are 63 and p to the power 3 minus 2. So 7 to the power 7 into p to the power 1, which is 7p. Here the reasoning is a to the power m divided a to the power n is equal to a to the power m minus n. So here it is p cube divided p square. So it is p to the power 3 divided p to the power 2, which is p to the power 3 minus 2. That is a to the power m divided a to the power n, which is a to the power m minus n. So a to the power m minus n. 3 minus 2, 1. So 7p to the power 1, which can be written as 7p. Question number 6. Divide. First one is 36 y to the power 8 minus 72 y to the power 6 plus 108 y to the power 4 divided 12 y to the power 4. In the numerator you can see we have got 3 terms, first, second and third term, and in the denominator only one term. So we'll try to find out if there is anything common in the numerator. We have got 36, we have got 72, we have got 108. That means 36 is a factor of 36, 72 and 108. So 36 can be taken common from all the 3 terms. Next, y to the power 8, y to the power 6, y to the power 4. So here the lowest number is y to the power 4. So y to the power 4 can be taken common from all the 3 terms. So when we take 36 y to the power 4 common, we are left with 36 into 36. That means one time it goes, so it will be 1. Then 4. So we are left with 4 here. Since here is y to the power 8 and 4 already we have taken common, so here we are left with 4y to the power 4 minus 36 into 272. So 2 into y to the power 2. Since 4 y to the power 4 we have taken common and here it is 6, so we are left with y square plus 3 divided 12 y to the power 4. Okay, since y to the power 4 we have taken common, so here left only 1, so 3 into 1 is 3. Now y to the power 4 and this y to the power 4 will cancel. Y to the power 4 and y to the power 4 will cancel out each other, and 12 into 3 is 36, so 3 y to the power 4 minus 2y square plus 3, which can be written as 3y to the power 4 minus 6y square plus 9. Now let us see this divide one more time. The question is 36y to the power 8 minus 72y to the power 6 plus 108y to the power 4 divided 12y to the power 4. So in the numerator we have got three terms, first, second and third term. Out of these three terms, what you can see, 36 is common to all the three terms, since 36 is a factor of 36, 72 also and 108 also. So we have taken 36 common. Then in the variable part, here we have got y to the power 8, here we have got y to the power 6, and here we have got y to the power 4. So while taking common, you have to remember, out of all the terms, the variable with the least power we take as common. So here the least power is 4, so y to the power 4 we have taken here common. So 36 y to the power 4 has been taken common from the three terms in the numerator. Therefore now when you have taken 36 y to the power 4, we are left with y to the power 4 in the first term. Reason is 36 y to the power 4 into bracket means multiplication. So into y to the power 4, whenever we multiply, we get 36 y to the power 8. Since bases are same, powers will be added. So 4 plus 4, 8. Original expression remains same here. Minus 2y square. So 36 into 2 is 72. 36 into 2 is 72. And then y to the power 4 into y square is y to the power 6 from the first laws of exponent which we have seen. So the second term we can verify. Third one, 36 into 3 is 108. 36 into 3 is 108 into y to the power 4. So this way also you can verify whether the common that you have taken is it correct or not. Next step, since there is a bracket, this means here it is multiplication. So y to the power 4 and y to the power 4 will cancel each other, and 12 into 3 is 36. So we are writing here 3, and then within bracket y to the power 4 minus 2y square plus 3, which if you multiply it, it will be 3y to the power 4 minus 3 to the 6, 6y square, 3 3 is 9 plus 9. Next question is 48. A cube b square c square plus a square b cube c square plus a square b square c cube, whole thing divided, minus 2 a square b square and c square. Now here what you find, we have got in the numerator, inside the bracket we have got three terms, first term, second term and third term. So accordingly we'll see the values here. 48. Now here it is a cube, here it is a square, here it is a square. So least power variable is a square. So we'll take a square common from all the three terms. Next we have got b square, b cube and b square. So once again least power variable is b square. So we'll take b square common from all the three terms. Next we have got the variable c square. Here c square, here is c cube. So once again c square is the least power variable. So we'll take c square as common from all the three terms. So we are left with a square, b square, c square since it is taken. So a square taken and here it is a cube. So we are left with only a. Okay, b square, c square taken, b square, c square already taken out. So we are left with only a. Then plus. Then you have got a square already taken common. So here it is 1. B square, here it is b cube. That means we are left with 1b, c square and c square 1. So a plus b. Next time would be only b. Third one, a square b square. A square b square taken, and here it is c cube and here it is c square. So we are left with 1c. Whole thing divided minus 2 a square b square and c square. So minus 2 into 24. If we multiply, we get here 48. So minus 2 will cancel 48 by minus 24. So 24. A square b square c square will cancel out each other. That is, a square and a square will cancel, b square and b square will cancel, c square and c square will cancel each other. So we are left with a plus b plus c. Therefore, we can write, if we multiply 24 with all the three terms inside the bracket, so we'll write minus 24a minus 24b minus 24c. You can keep your answer here also. And let us see one more time, how do you take common. One thing we have to remember, when we take common from the terms, that particular variable or the number has to be there in all the terms. So here it is a cube, here it is a square, and here it is a square. So always we take the least power variable as common since it is there. So a square we have taken common. So when we take a square common, here it is a cube.